It sounds like something out of a science fiction movie, but today we're looking at a real-life piece of engineering that does exactly that. Get ready to be amazed, because this cliff-climbing excavator is about to redefine what you thought was possible in construction and excavation. First, let's just take a moment to appreciate what we're seeing. This isn't a gentle slope or a hilly terrain. We're talking about near-vertical rock faces, the kind of places you'd expect to see professional rock climbers, not a heavy-duty piece of machinery. Yet, here it is, gracefully and securely making its way up and down, like a mechanical mountain goat. So, how on earth does it work? The secret lies in a brilliant combination of hydraulics, winches, and some very clever engineering. The machine is essentially a modified excavator, often called a spider excavator or walking excavator due to its unique, leg-like stabilizers. But what takes it to the next level for cliff work is the anchoring system. At the top of the cliff, a powerful primary winch is securely anchored into solid rock. This isn't a simple hook. We're talking about deep-drilled anchors that can withstand immense forces. A heavy-duty steel cable runs from this winch down to the machine itself, acting as its main lifeline. This cable is responsible for bearing the majority of the excavator's weight, preventing it from plummeting to the ground. It's the ultimate safety net. But the machine doesn't just hang there passively. That's where the spider part comes in. The operator inside the cabin uses the machine's own hydraulic arm and bucket to maneuver. By digging the bucket's teeth into the rock face, the operator can create anchor points. They can then use the arm to push or pull the excavator, effectively helping it climb or reposition itself. Think of a climber using an ice axe to find a hold and pull themselves up. It's a similar principle, just on a massive, mechanical scale. The 4 independently operated legs or stabilizers are also crucial. They can extend, retract, and angle in almost any direction. This allows the machine to brace itself against uneven surfaces on the cliff, providing stability and preventing it from swinging around wildly. The operator can adjust each leg individually to find the most secure footing possible, creating a stable platform to work from. It's this 3-point system, the main winch cable, the excavator arm, and the stabilizers that gives it such incredible and secure mobility. So, why would anyone need a machine like this? The applications are more common than you might think. This technology is a game changer for hillside stabilization projects. When there's a risk of landslides or rockfalls threatening roads, railways, or buildings below, these machines are brought in. They can systematically remove loose rock, a process known as rock scaling, making the cliffside safe. They are also used in quarrying and mining operations where valuable materials are located in difficult-to-reach vertical seams. Instead of building expensive and environmentally disruptive access roads, these climbers can go directly to the source. Furthermore, for specialized construction projects, like building foundations for bridges or observation decks on mountain outlooks, these machines are indispensable. They can prepare the ground in places where traditional equipment simply can't go. The skill of the operator is just as impressive as the machine itself. These are highly trained professionals who need a deep understanding of geology, engineering, and have nerves of steel. They're not just driving a machine, they're performing a delicate, high-stakes ballet on the side of a mountain. Every move is calculated, from the placement of the bucket to the tension on the winch cable. They use a combination of controls, joysticks, and pedals, all while suspended hundreds of feet in the air. Looking closer at the process, the work is slow and methodical. The operator might spend hours in a small section, carefully breaking apart unstable rock formations. They use various attachments on the excavator arm, not just a bucket. They might use a hydraulic hammer to break up large boulders or a drill to install rock bolts, which are long anchors that pin unstable layers of rock to the more solid rock behind them. Safety is, of course, the #1 priority. The systems are designed with multiple redundancies. The winch cables are rated to handle many times the machine's actual weight. The hydraulic systems have fail-safes, and the operators are in constant communication with a ground crew. Before any work begins, geological surveys are conducted to assess the stability of the rock face. It's a highly controlled and scientific process from start to finish. This technology represents a major leap forward. Before these machines existed, this type of work was incredibly dangerous and labor-intensive, often requiring teams of workers to rappel down cliffs with handheld tools. The cliff-climbing excavator has not only made the process significantly safer but also much more efficient and precise. It's a testament to human ingenuity. We see a problem, like an unstable cliff, and we don't just find a solution, we build a giant mechanical spider to crawl on it and fix it. From securing our transport routes to enabling construction in the most extreme environments, These incredible machines are quietly working behind the scenes, shaping our world in ways we rarely get to see. They are the unsung heroes of modern engineering, proving that with the right technology, even the steepest challenges can be overcome. So the next time you drive past a steep rock cutting on the highway, take a second to think about the incredible engineering that might have gone into making it safe. It could have been one of these amazing cliff climbing machines. Thanks so much for watching. If you were as amazed by this piece of machinery as I am, be sure to hit that like button and subscribe for more deep dives into incredible engineering. Let me know in the comments what other amazing machines you'd like to see featured. Until next time.